Hello, this is Matt Roscoe at the University of Montana with a short video on our section 12.7, areas of irregular shapes, for today's lecture in Math 133. Let's get started. I want to talk to you first about what we do in mathematics when we're given an irregular shape, and then do two examples. One of the examples I'm going to do full, and the second example I'm going to challenge you to do on your own and to submit a picture of it in the I guess the forum, the discussion forum that is up on Canvas just below the link to this video. All right, so let's talk about irregular shapes. Sometimes shapes are irregular, meaning, they're not nice squares or rectangles or trapezoids. And so finding their area is often difficult to compute, at least in an exact sense. So what we have to be happy with in those cases is an approximation. This is what happens when people apply mathematics to the world. Oftentimes the shapes that they're trying to find the area of are irregular. So let's say if you wanted to find the area of the surface of a lake, for example, which is highly irregular. So what do we do in those cases? We use approximations. Let's take a look at an example. One that's close to my heart is Wild Horse Island. It's the largest island in Flathead Lake. It's like a small mountain that grows out of the middle of this lake. It's gigantic. I've been out there hiking a few times and run into the big herds of bighorn sheep that are out there. It's used as a transplant population for all of western Montana. It's a nice place to grow a sheep herd because there aren't very many predators. Anyway, the question I have is how many acres is the island? Remember that an acre is about is exactly 43,560 square feet. Okay, well, let's see if we can figure out this question. So here's a picture of Wild Horse Island. Here's an inset map of where it can be found on Flathead Lake. You can see Polson at the bottom and Big Fork, Summers Lakeside at the top. You can see it's kind of, in this big bay off to the west side of the lake. It's kind of a blobby looking island, somewhat circular, but certainly not a circle itself. The question is how many acres is that island? Well, we're given a scale up here, and so maybe we could just use that for starters to get an initial estimate. So what I'm going to do is use the nice digital tool I've been given. I'm going to find out exactly, too fat, let's see, I want to do it that. Find out exactly how long a mile is. Let's see, I'm going to do it in red maybe, just so we can see it. So here's a mile. There's a unit that's a mile, and so what I could do here is I could copy it and paste it, and put another one next to it right there. And then paste it again, and put another one next to it right there, and paste it again, and rotate one up, and do something like that. I guess paste it again here, rotate it up, and do something like that. Paste one more again here. Keep moving. So in essence, what I'm doing is I'm creating a grid squares, I guess, using the 1 mile distance, and get us an estimate of roughly what's going on this island. I don't know, I guess we could put a couple more down here on the bottom. Hope this is making sense to you, how this will help us. Okay, so now we have a sense that it's definitely under 6 square miles, because 6 square miles are a large overestimate of the island. But I would say it's definitely bigger than 2 square miles, so somewhere between 2 and 6. And then the question is, well, how could we get a better sense? One of the ways you can do this is think of chopping up pieces of the leftovers. So let's see, I'm going to go here and think about this one. So if I took this part away, and sort of shoved it up here. I mean, and I know it's not probably perfect, but that looks like it's roughly the same area. Then I would have 1 full square mile right here. So that's one thing we could do. Like my arrow. Okay, fine. Oh. There we go. Let's see. So let's take this piece now. If I took this, I think, I mean, when I look at it, I think, roughly it could go down here as this area down here. I could call that 2 square miles then. And then what's left over is the big question. I mean, I don't know if you agree, but it does look like it works out pretty darn close. If I take this area, right, and shoved it into this area. I don't know if I need to. Let's do that. Somewhere in the neighborhood of 3 square miles is what I'm guessing. Somewhere in the neighborhood of 3 square miles, using what we've been given in terms of the the mileage legend on the map. Okay, so that's certainly one way we could get a rough estimate. So I'll just say off to the side here, rough estimate, 3 miles squared. How could we make it better? So that's the next question I guess I would have. How can we improve the method of estimation that we've used in here, which is literally counting grid squares and then multiplying by the area of the grid square, which in this case was a square mile. I think, it's pretty clear that one way we could do this is to use smaller squares, right? So you could overlay on the island some sort of grid square graph paper, and then use that to try to dice up and find out what the area of the island is. Does this make sense? Sorry, I'm sipping a little tea here. My throat's a little bit off today. So let's do it that way. Let's first count how many squares we think there are. We'll count how many whole ones there are, and then we'll sort of use estimation to put together the leftovers. And then once we have an estimate of how many squares there are, we'll dive in and try to figure out what the area of a single square is. I can see that a single square is quite a bit less than a square mile here, because if I look at the scale of the mile, it looks like it's quite a bit smaller than what a square mile would be. Okay, well, let's go ahead and find out how many whole squares there are. I'll start in red. I'm going to start in this corner. Actually, I want a thicker line, so I'll redo that just so we can see it. There we go. So that would be, I guess, the border of whole squares. I'm coming over here to this one, down here to this one, over to that one. See, down here to this one, over to that one, all the way down to this corner, I guess. And then over one, down one, all the way over to this side. Looks like I go up to here, over to there, up to here. Oh, I guess over to there, up to here, over to there, down. I'm going to count that one as whole, even though the little corner is out of it. Up to there, over to here, up to here. Guess over to here, up to here, over there, and up to there. Okay, so we can see that would be one, I guess, a set of squares that would be an underestimate, right, of what the the area of the island would be. Let's go ahead and count them while we've got them sitting in front of us. I'm going to do some dicing. So I'll cut there and here, I guess. Cut here and here. I'll cut down here and over to here. Cut there and there. I guess here and here and there. Okay, so I guess this is a 1, this is 4, this is a 3 by 4 or 12, this is a 2, this is a 3 by 4 or 12, this is a 6 by 6 or 36, this is a 1, a 2 by 3, so 6, a 1, and a 1. So let's go ahead and count up squares, or I guess areas from biggest to smallest. We have 36 plus 12 is 48, plus another 12 is 60, plus 4 and 6 would make 70, plus, let's see, 2, 72, no, wait, yeah, 4 and 6 is 70, plus 2 is 72, and then all the ones, 73, 4, 5, 6, 7, 8. So 78 red squares, I guess. I'm going to count them again just to make sure I got it right. 36 and 12 is 48, plus 12 is 60, plus 6 and 4 is 70, plus the 2 is 72, and then there is 1, 2, 3, 4, 5, 6. 6 plus 72 is 78. Okay, so I'm pretty happy with that. Now I'm going to go on and count the edge pieces. And this is where we're going to have to estimate, right? So I'm going to start at East Shores right here. And I'm going to say that all of these ones together make 1. And I'm going to say that this one, if I put down with these two, together would make 2. It might be a little bit generous, but I'm going to go with it anyway. I'm going to say that if I put this guy right into here, I would have a 1. I'd say that if I took these ones here out and shoved them in with that one, I'd have a 1. So I'll do it like this, 1. Let's see. How do I want to do this one? I'm going to put this one with that one, and I'll make a 1. I am going to put this one with that one, and it would make a 1. And I'm going to put this one with that one, and it would make a 1. Okay, so that one's out, that one's out. Okay. Yeah, a little generous, but I'll go here and call that a 1. I'll go here and call this a 1. Yeah. I'll just do it this way. I'll call that one a 1. Is that right? That doesn't look like it's enough. Let's think that one over again. I don't like that one. Let's think here. How could we do this better? Let's see. So this little piece right here, if I put it right there, I would say that would make this one a 1. Okay. I'm going to say it's a little bit generous, but I'll put this one with that piece right there and make that a 1. So that one goes there. I'm going to put this one down with that piece right there. And that would make this one a 1. And I think this one would go pretty well with that piece right there. That would make this one a 1. I think if I put this one together with that and this one together with that, then this one would be close to a 1. So those would get used up. Let's see. I think if I split this one between here and there, then this one would be a 1, and so would that one. And then let's see, I think if I shove this one up into that one, we'd have a 1 here. And then I'm just left with a little bit left over here. So what do I want to call that? I guess it looks like 0.75. So let me see here. I'll call it 0.75 here. And that one we already got rid of. Okay, so now counting around from East Shores, I have 1 plus 2 is 3, plus 1 more is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 3/4. So it looks like that's going to give me 96 3/4. So that's my total area count for squares. Now all I need to know is what is a square in terms of, how big is a square in real world units. You'll want to be really careful when you do this, because once you pick that size, you multiply it by 96. It's really going to magnify your error if you make a mistake. So let's think this through really carefully. I'm going to use pink here. So here's the way I'm going to think of it. I'm going to say, well, this distance right here, oops, too fat. This distance, too skinny. Let's see, right in the middle, just right. Sorry. This distance right here in real world units is 1/2 mile, right? On the map, what it occupies is this distance. I'm going to be careful here. On the map, what it occupies is this number of squares, right? And it looks like it is 2 full squares plus about 3/4 of another square. So I'm going to call it, the way I'm thinking 3/4, there's a 1/2, here's a 1/4, there's another 1/4. So it seems to me like it's 3/4 or maybe just a little bit, 4/5. I don't know. Depends on what your eye sees there. I see it as 3/4, where those are, maybe 4/5 would be closer. This is really really hard thing to get a sense. I'm going to go with 3/4. So this is 2 3/4 units, right? Is equal to a 1/2 mile. So what we really want to know is what 1 unit is equal to. So if I take 2 3/4 units and divide it, if I take 1/2 mile and divide it by 2 3/4 units, then that tells me how many miles per unit, right? So if I take a 1/2 mile, 0.5, and I divide it by, so what I'm doing is 1/2 of a mile is equal to 2 3/4 units. And what do we get out of that is the question. So 2.75, 0.5 divided by 2.75, we get 0.18 repeating, and that's miles per unit, right? So that's where, now we can use that to determine what the area of just one square is, right? So I'll take that idea and I'll move up here, and I'll think to myself, okay, so if I draw a square, what I know is that square is 0.18 miles on one edge and 0.18 miles on another. And so if I just multiply the length times the width, so 0.18 repeating, really, I'm going to use the repeating decimal to stay as accurate as possible. So take that answer and square it. I get 0.033. Yeah, it's going to be hard to see in here, so I'll switch to 0.033 square miles. Does that make sense? So what I did is multiply 0.8 times 0.8, and I got 0.033 square miles. So that means one of these squares is roughly 3/100ths of a square mile. So I need roughly 30 of them to make a square mile. So that's going to be a really important number in my next, next page when I come to an answer. So let's go ahead and figure out an answer here now. What did we get? We got, I'm going to change my pen color to black and say, well, we got 96.75 squares. And we're going to multiply that by 0.033 square miles per square. And what we're going to get is an answer out in square miles. So I'll take this number times 96.75, and I'll get 3.198. And what's kind of neat is that that's pretty darn close to what we saw when we did our first initial estimate. We thought the initially, just rough guess was around 3 square miles. Well, now we have a much more accurate guess, about 3.2 square miles. Let's find out what that is in acres. So 3.198 miles squared. Let's do a little dimensional analysis, see if we can wake that beast up again. So let's see, if we want to first cancel miles, what I want miles on the bottom and feet on the top. So 5,280 feet in a mile, but we have square miles, right? So we want square feet, so that means we'll square the linear conversion to find out how many square feet are in a square mile. It's a lot, somewhere in the neighborhood of 25,000, or 25 million, sorry. Okay, so at this point we would be in square feet, and then we know that there are, in 1 acre, which is what we were trying to get to, there are 43,560 square feet. So this will give us acres. And let's see what happens. I'll take the 3.198 times 5280 squared and divide by 43,560, and I get 2,047 acres in our estimate. So about 2,000 acres on that island. It's a healthy size island if you have a sense of what an acre is. Let's go ahead and see what Google says. I think I already had this pulled up. Yeah, so it turns out the park site is about 2,160 acres if you go by FWP, 164 if you go by Wikipedia. And of course, these are estimates, right? Somebody used GIS to make estimates here, and but we have an estimate ourselves, and it's pretty darn close to what they were. We're within at least, we're within about 100 acres, 110 and 12 acres, 113 acres on a 2,000 acre measurement. So what is that? Let's see. If I take 110 divided by, I don't know what that answer, let's see. So yeah, we're within 5% of the established value, or at least the value that's being advertised on the internet. Okay, I hope that makes sense. Let's sort of savor this a little bit. So number one, if we have an irregular area, then really we're left with one choice, and that choice, of course, is to deal with approximate areas, right? And if we're going to do approximate areas, then what we have to do is adopt some system of counting areas that we know. One way to do this is to sort of draw grid squares over the irregular shape and estimate, what pieces can go where, and come to a general estimate of what you think this would be. We did this with square miles. We came up with an estimate about 3 square miles. But we, of course, wanted something a little closer than that, so we went to grid squares that were much smaller. We first computed the red count of whole grid squares, which we're pretty confident in those areas, but it's the green ones, right, where we're definitely eyeballing and estimating. And we just, took a look at what pieces seem to fit together to make estimates. and counted those all up. We got 78 red grid squares, 18.75 green ones, added them together for 96 3/4. And then the question was, well, what's a square? So we took the scale and decided, well, a half mile is about 2 3/4 units. That turns out to be about 0.18 repeating miles per unit. If you square that number, it tells you how many square miles are in a square. And so we came up with this number, 0.033 square miles per square. And then we can just off to the races with arithmetic. Take 96.75 and multiply by 0.033 square miles per square. And we got 3.198 square miles for the island. And then we used dimensional analysis to arrive at an acre estimate of about 2,047. And we were within 5% of what I guess the advertised value is on Wikipedia. All right, let's do another example. This one I want you to try on your own. So how many square miles is Yellowstone National Park? Suppose that you wanted just a quick estimate. How could you produce an underestimate and an overestimate? So do a quick estimate like I did. So by quick estimate, I mean something like this, something wild and quick and easy, right? Okay. And then you could either use the two estimates to take a guess, or you could actually use smaller grid squares to come up with a very good best estimate. But what I'd like you to do is produce an underestimate and overestimate, and then give me a best estimate, and show me how you did that. Here's the picture of Yellowstone National Park that I'm giving you. Notice that it does have a mile scale. We're going to just work in square miles since this is a very large park. So go ahead and use the handout that I've given you. Let's see, I'm going to get rid of that. Would you work over here on this side of the page to get a sense of, oh, I see I have stuff drawn from last time I taught this. Let me just get rid of this. There we go. Would you work on this page to give yourself an underestimate, an overestimate, and then a best guess. It is a fairly straightforward one. If you take a look here at the mile scale, it just so happens that the things are pretty nicely laid out here. You can see that 20 miles is just over 4 grid squares, so 4 units. So you might use that in your, well, you're going to want to use that in your conversion. Looks like 20 miles is about 4 point, I don't know, what would you call it, 4.1 or 2 units. So that'll get you a very nice, easy handle on how many square miles are in a square, and then it's off to the races and counting squares. Again, a quick and easy underestimate, overestimate, and then best guess. And if you would work that through, should take you 15 or 20 minutes to do, work that through and take a picture of your work. I assume you're probably going to have to work both on this page and another page, just like I did on the last example, right? I had a page where I did all of my counting and figured out what a grid square was, and then I had another page where I did the multiplication that led to my answer. So something like those 2 pages, but 3 steps. I want to see an underestimate, an overestimate, and then a best guess. And I'll just challenge you not to peek until you actually get an answer. I'd be really curious to see how close we are. But if you'll go ahead and complete that, and then take a couple pictures of it and share it on in the discussion forum called Yellowstone National Park Discussion. We'll take a look at these on Monday when I get back and debrief this unit. Okay, well, that's about it for today. I hope that you got a good sense of what of this technique and that you are better prepared to teach it to children in the future. Okay, have a great weekend, everyone. I'll see you on Monday.